Hello everyone. My name is Alistair Saldana.
Samarth Tumdi.
And Atharva Asher.
We are going to explain about our IPD project, which is Soul Sound Advanced Music Recommendation System. This is the agenda of our IPD project. So we know that music is one of the most popular entertainment media when we are considering in this digital era. It is considered as the work of human creativity to express the ideas and emotions in the form of different sounds like melody, harmony, and rhythm. It is also categorized into several genres such as pop, rock, jazz, etc. Listening to music has become quite easy due to the advancement of technology. It is available offline and online. And with many music items available on the internet, the task of finding acceptable and preferred music has become quite difficult. So, music recommendation systems helps us to solve this problem by helping the users to filter from the many songs available and discover the songs of their choice. Moving on to the analysis of literature survey. The first literature is about music recommender system based on genre using convolution recurrent neural network. The methodology used here is CRNNS, which is a combination of convolution neural network and recurrent neural network. Dataset used was Free Music Archive, and the performance evaluated using precision, recall, ROC curve, and F1 score. The results came out to be F1 score being approximately 0.75. The next paper is Music Recommendation System, which is from International Journal of Engineering Research and Technology. Methodology used here is ANN and KNN. Dataset used is million song dataset. The performance evaluated was a graph, which is of loss function versus epoch, where the results came out to be loss function decreasing with increasing in epoch. Analysis of music recommendation system using machine learning algorithms. The method used in this paper was collaborative filtering, and the dataset used is million song dataset. Performance was evaluated using precision, recall, and F1 score, where RF came out to be 0.74 and XGB was approximately 0.74. The next paper was about personalized music recommendation system. Again, the methodology used is collaborative filtering, and they used their own data set here. Performance was evaluated where CNN was in the context of emotion recognition, and the results was classified into emotions of 4 moods. Next paper was deep learning in music recommendation system. The method was content based. Dataset used was million song dataset, and the performance was evaluated using AUC curve, where the results came out to be 0.772.
Okay, so the gaps in the development of previous music recommendation systems noted from all the references are summarized as follows. The first one is personalization. Despite advances in machine learning and artificial intelligence, many music recommendation models still struggle to personalize recommendation effectively. Models should take into account individual user music taste and preferences more accurately. The second gap is cold start problem. One of the challenges of music recommendation models is the cold start problem, where the model has limited or no information about a new user's music preferences. This makes it difficult for the model to provide accurate recommendations. The third gap is diversity of recommendations. Some music recommendation models tend to focus on popular songs, leading to a lack of diversity in the recommendation and underrepresentation of talented upcoming artists. Models must provide recommendations from a wider range of musical genres and artists to incentivize appreciation for under-recognized talent. The fourth gap is evaluating recommendation. There is a still lack of standardization in evaluating the performance of music recommendation model, making it difficult to compare the effectiveness of different models. Further, the next gap is incorporating user feedback. Some music recommenders rely solely on past listening history to make recommendations. However, user feedback such as explicit rating or song skipping behavior can also provide valuable information for improving recommendations. Models need to effectively incorporate this feedback. Our problem definition is to develop a music recommendation system by following a hybrid-based approach for filtering recommendations.
This is the proposed design where the proposed design is divided into three phases. In the first phase, we'll have the user create an account and register on our website, which is the sign up or login. The new user will be asked to provide the basic informations like their name, password, age, gender, which will make their profile. And then these details will be stored in the user DB created on MongoDB. Along with that, the user's listening activity would also get stored. After a successful sign up, the user will be presented with our UI and get the recommendations accordingly. In the login part, existing users will be able to log in their existing profile to use our service. The system will fetch all the available data for that user based on the login. Considering music data, we have decided to use the Spotify API and JioSaavn API to get the metadata and audio features for the songs respectively.
So moving on to phase 2, which comprises 4 components each based on a different filtering technique. Going over each component, first up is content-based filtering, where songs are matched using the vectorized audio features and cosine similarity. The songs which are most similar and not listened to by a user are recommended. Collaborative filtering is where instead of songs, we match users using their listening activity and cosine similarity. Mutually exclusive songs are recommended. Popularity based recommendation is where we use the popularity score provided by the API and recommend the most popular songs. Pseudo random recommendation is our creation where we use the lower ranking results of the previous components and randomly recommend a song out of them. To combine the results from all the components, we use the weighted combination approach. Here, 70% weightage is given to content-based, 20% to collaborative, and 5% each to popularity and pseudo-random components.
So in phase 3, the user's actions on our recommendation is recorded as feedback. This feedback includes if a song from the playlist was flipped. This is used for further improvement on the previous recommended playlist for that user specifically. Moving on to data description, the dataset contains information about the songs stored in our music database. There are more than 1,000 unique songs in our dataset, each representing a song's information. The columns in the dataset include track ID, track name, primary artist, language, and audio features of the song, and many other columns. The dataset was generated by combining the data from JioSaavn and Spotify API. Metadata of each song was fetched from JioSaavn, and audio features were fetched from Spotify API. The metadata was used for website and the model, whereas the audio features were used to find similarity between the songs for the model.
Before the result analysis, we would like to show the demo of our product.
So this is our sign up page where we have asked the users to enter their username, email, password, gender, and age. We'll start with the login page now. This is the homepage UI which the user will get once he or she is logged in. Initially, it is just the normal popular songs that are available in the recommendation. But once clicked on a particular song, the recommendation list would change according to the songs. And this is the recommendations that are provided based on the song and the user.
Coming to the result analysis of our recommendation system, In total, 50 users were recorded using this application. A separate dataset was created for these users to analyze the performance of the recommendation system. Separate columns are created with data collected from the first listening session, new login, second listening session, more user data, and third listening session, even more using data, user data, and more users altogether. As recommendation systems do not have a standardized testing procedure, this product is tested on custom test cases aiming towards maximized personalization. Test case 1, click-throughs. Total clicks on songs in a playlist. Here we've checked trends in clicks received on the songs recommended by the system. 13 out of 50 users showed an increasing trend in clicking the recommended songs, whereas 16 out of 50 users showed a decreasing trend and 21 out of 50 users showed a varying trend in clicking songs. So, summarizing test case 1, we can say that the majority showed variation. It may come off as an underperformance, but it is to be noted that clicks are not the most reliable metric. That is why we move on to test case 2. Test case 2, duration per playlist. Here we have checked the total duration a user has spent on a playlist. 29 out of 50 users showed an increasing trend in time spent. 8 out, 8 out of 50 users showed a decreasing trend in time spent, and 13 out of 50 users showed a variation in time spent on the app. Summary of case 2. Majority of the users showed an increasing trend in time spent on our app, which suggests an improvement in the recommendations over time. Still, to improve our metric even further, we move on to test case 3. Test case 3, score per playlist. This is a normalized version of test case 2 since we are now also considering the actual total duration of the songs to calculate a score using the formula shown. Here, 28 out of 50 users showed an increasing trend in the scores, 6 out of 50 users showed a decreasing trend, and 16 out of 50 users showed a variation. So, test case 3 also concludes with similar results as test case 2, indicating that with time, the recommendation system improves user satisfaction.
So we will conclude this presentation. The use of efficient and accurate recommendation techniques is very important for a system that provides good and useful recommendation to its individual users. The system provides state-of-the-art personalized recommendations with just the right amount of differentiation from the user's taste to incentivize trying out new items, thereby increasing user satisfaction and retention. The model presented here is prone to changes for even better performance. Future scope of our model, we would like to train on more music features to improve the accuracy of the system, possibly even derive music features on its own using deep learning. The second point is demographic based recommendations as well as time of the year based recommendations. Focusing on making personalized recommendation by making the fraction of the four components flexible. That is, the fractions change for each individual. The proposed system database currently contains 1000 plus songs, and since there are millions of songs available, integrating big data technology can solve the issue of storage and recommendations can be made available within seconds. So these are some of the references that we have used. Thank you for listening to our presentation. Bye.